So what I want to do with this video is just really quickly, hopefully, go through the equation for Ohm's law. I'm not going to worry about any exciting stuff about the history of Ohm's law or how it was discovered, etc, etc. I'm just really worried about you talking, or you being able to use this equation to solve problems and what it means. Now, Ohm's law just gives us a relationship between these three things for maybe a whole circuit or a component in a circuit or a combination of either, really. Potential difference is measured in voltage, current is measured in amps, and resistance is measured in ohms, named after Mr. Ohm himself. It's this funny squiggly symbol, a bit like the YellowMan is wearing here. Now, if I have a circuit or a component and I know two of these values, I can use this equation to work out the third value. Doesn't matter which one it is, I can rearrange this equation to make whatever I'm trying to find the subject. Right, so anything else we need from this? For the GCSE, for AQA specification at least anyway, you are supposed to be able to remember this equation for the exam. So I think the best way to learn equations is just by learning them like a phrase. Potential difference is equal to current times resistance. Potential difference is equal to current times resistance. I'm bored of that already. Now, let's have a look at a problem. Let's just move him. And let's go straight onto here. So, I've come up with this question here. A bulb has a resistance of 6 ohms and a current of 2 amps flowing through it. Calculate the potential difference across the bulb. And I said that this is potentially worth 4 marks. Right. When we come to this problem, well, we already know that I want the Ohm's law equation for this, so no big surprises there. Normally when you're approaching a physics problem, you think, what equation is going to help me out here? But let's not worry about that at the moment. So the equation we're going to use is, can't be bothered to write it all out, so I'm going to write pot diff equals current times resistance. Let's have a look in here. Where's my value of resistance? A bulb has a resistance of 6 ohms. That's my first value. And a current of 2 amps flowing through it. Calculate the potential difference. Calculate the potential difference. This relationship here, Ohm's law, tells me potential difference is equal to current times resistance. So, take my values. First thing I want to put in is the current. Got a value of 2 amps, so it's 2. Current times resistance, the value of resistance I've highlighted in the question is 6 ohms, so 6. So my potential difference, the thing that the question has asked me to calculate, is equal to 2 times 6. Gives me a value of 12. Now, all good physicists, and generally in the exam there will be a mark for remembering what the unit is. In this case, it's the funny hat that Ohm wore. It's 12 ohms. Now let's go through this and see where the marks come from for such a question. First mark, remembering the equation. Second mark, putting those values into the equation. Third mark, correct answer of 12. Fourth mark, remembering the unit for ohms. Right, quick question change, very smooth that. Just one more example to go through with you. This one is going to involve a bit of rearranging of the equation. So again, a resistor has a potential difference of 12 volts across it and a current of 3 amps flowing through it. Calculate the resistance of the resistor. Don't need to remember the equation, a bit too obvious what we're doing at the moment, but where's the information in the question? I've got a potential difference of 12 volts and a current of 3 amps. Calculate the resistance. I've been generous I said let's go for 5 marks here. Not always quite the case, but let's be kind to ourselves, I guess. Right, now potential difference is equal to current times resistance. In this equation, in this problem, I've got 12 volts potential difference. So first thing I know is 12 is equal to current, it's 3 amps, times resistance. Oh, hang on a minute, it's asked me to calculate the resistance, so I don't know what that is. I'm just going to write resistance. I need to get resistance on its own in this equation. I've got times by 3 on this side, so I do the opposite operation to balance it out. 12 divided by 3 cancels that and leaves me 12 divided by 3 equals resistance. Never leave your answer as a fraction in physics. We don't like it because it means it's accurate to infinity, which isn't possible. So 12 divided by 3 is equal to 4. So my resistance is actually equal to 4 ohms. Now that's just going off the bottom of the screen. Let's just move that up ever so slightly so we can see. Let's go through and mark it. Different colour pen. First mark, boom, remembering the equation. Second mark, substituting in the values. Third mark, correct rearrangement. Fourth mark, correct answer. Fifth mark, remembering the units. All done. Alright, thank you guys.